Hello, this is Bob Sluka from Russia, and thank you for letting me chat with you today about some of our microplastic research at Canaveral National Seashore. I'm going to share my screen and put up a PowerPoint, so I think that will be much more interesting than looking at myself. So what I'd like to do is, see if I can do this, yeah. So is talk to you about Nurdles. What are they? Where and when do they appear on beaches of Canaveral National Seashore? And why does it matter? So thank you for spending the time to listen today. I want to give some special thanks to collaborators, Dr. Ann Patterson and Steve McMahon of Williams Baptist University, along with interns, Kayla Pickman, Paige Johnson, Kristen Micklemore, for help with fieldwork, data entry analysis. Great time together last May as interns. Thank you to Bosch for making it possible for that to happen. Brittany Ederer, my colleague here in Titusville, assisted with a lot of the data collection, and a large number of volunteers, and my family participated in a lot of Nurdle hunts. So grateful to them for putting up with me, and also gratefully acknowledge permission to conduct the research in the National Seashore. Plastic pollution in the ocean is pervasive and very well documented. Since its development in the 1950s, it has expanded in its use, and some have even suggested that we will be able to mark this time geologically as the start of the Pleistocene era. However, as one paper put it, plastic is not plastic is not plastic. There are several basic chemical formulations of plastic, some names of which are relatively well known, such as polyvinyl chloride, PVC, or polystyrene, this ubiquitous foam, coolers, or peanuts in packaging we're also familiar with. But to each of these starting points, a whole array of chemicals is added to change the properties, colors, and uses, such that there are thousands of types of plastic in global circulation. We know that plastic is found in every marine habitat that we have looked, from the ocean surface to the deep ocean trenches. To date, more than 700 marine animals have been recorded as encountering plastics, usually by ingestion. Obvious detrimental effects on wildlife are seen, for example, in seabirds from oceanic islands or juvenile sea turtles who wash up on Florida beaches dead, with stomachs full of plastic. There are indications that plastics absorb and give off chemicals which could be detrimental to both animal and human health. Larger pieces of plastic break down into smaller pieces called microplastics, which are by definition less than 5 millimeters in size. This is about the size of a lentil or small bead. These small pieces broken down from larger pieces are known as secondary microplastics, as they derive from previous sources. Primary microplastics are made that size, for example, microbeads used in many products instead of natural scrubbing agents. The science is still relatively new, and so there is yet to be a standard categories for microplastics. But these are often thought of as being foam. Think again, the styrofoam beads on the beach, film, wrappers and such, fragments broken down from bigger plastic, filaments, strands from clothes or rope, and plastic pellets, the latter also known as Nurdles, or more prosaically as mermaids' tears. It is these latter microplastics that our study focused on, Nurdles, the basic element in most plastic production.
Holding a microplastic bead on the beach.
These are created from hydrocarbons, an issue that still impacts on climate change, but which we don't really have time to engage with here. Then these small pellets are shipped to factories, which they are then processed and made into the plastic items that we use on a daily basis. It's here that I want to digress for just a moment to make clear that plastic is not a good or bad thing. There are many, many situations where plastic use is incredibly helpful and many times environmentally friendly, for example, in reducing weight in vehicles. While we will not dwell on the ethics and morality of plastic use, something we have written on in other places, we need to seriously consider how our use of this tool does result in outcomes that we judge to be moral or immoral, good or bad, and particularly its impact on those who have no say in nor understanding of the problem, the creatures of our beloved oceans, and in this specific case of Canaveral National Seashore. Back to Nurdles. After they are produced in a chemical plant, they are shipped to factories and businesses that use them via boat,
manufacturing picture.
They are then transferred to the plastic manufacturer where they are stored and utilized to make all the varieties of plastic that we use. At each point, there's a possibility of pellet loss. A holistic approach is therefore necessary to combat nurdle loss, ranging from reducing manufacture, loss in transport, loss in factories, and so on. A whole supply chain approach is necessary, and awareness at all levels. This diagram was made by FIDRA, which is a Scottish NGO that's been working in collaboration with many others, particularly in Europe, but to chart the course and the sources and sinks of nurdles throughout the world. And it's a group that Arash has partnered with throughout our national organizations all over the world. And so they've put together this diagram and a helpful analysis of how we can really interact with the whole chain in order to reduce nurdle pollution.
Jar with microplastics on the beach.
The enormity of the issue and the need to understand the places where nurdles are found has resulted in both universities and NGO research and citizen science research projects globally. The Great Global Nurdle Hunt that I mentioned from FIDRA is one example. More recently, Nurdle Patrol has formed to examine nurdle abundance in the southeast of the US, particularly the Gulf of Mexico. And Florida has its own microplastics awareness project with citizen science research into microplastics in the water column. So for our study, we wanted to understand initially at a very simple level, are there nurdles washing up in Canaveral National Seashore?
Beach photo.
Pilot studies indicated that this was so. And then subsequent questions became, how does nurdle abundance change in space and time at Canaveral National Seashore? Today, we are reporting on our initial investigations, year one of a 3-year project. Conclusions are necessarily tentative and help us to move forward in a way that increases our understanding of the issues and the value of this approach. The study was proposed and is being implemented by Arash USA's Marine Conservation Program, whose base is Titusville. We are a Christian conservation organization conducting research, community conservation, and education in the USA and globally in 20 countries on 6 continents. We are faith-based, but not faith-biased, working with anyone who wants to join along with any faith or none. We also conducted a good portion of this study in collaboration with Williams Baptist University in Walnut Ridge, Arkansas, as part of a project to increase access to STEM research for rural and students who might not have this type of opportunity for a variety of reasons.
Students on the beach.
We gratefully acknowledge the Bosch Corporation for funding the participation of Williams Baptist students and their 3-week immersive STEM experience on the Space Coast in 2019, which we hope will be repeated here in 2020. The basic methodology for a nurdle hunt is quite simple. Search the high tide strand line or storm strand line on a sandy beach for a set period of time with a given number of individuals. Here's my son, happily taking part in a nurdle hunt. In this study, we held the amount of time search constant to 15 minutes, but did not predetermine the number of individuals that would complete the survey. This allowed for the method to be used educationally and as a citizen science approach through local students at Titusville High School and Eastern Florida State University, local church groups, visiting individuals interested in Arash's local work, and collaborations such as with Williams Baptist. Numbers of observers range from 1 to 9, with the average being 2 to 3 participants per nurdle hunt. The high tide strand line is that portion of the beach where the most recent high tide has washed up debris, both organic and plastic. You can see it here in this photo in the debris that's been washed up there. My son is right in the middle of it. In this case, the high tide strand line is right up next to the storm strand line. You can see the waves have eroded some of the dunes there. And so in this area here is where you would find most of the plastic that had been washed up either through storms recently or as a result of the last high tide. So this is the area that we search in for this 15 minutes. A storm may cause significant wave action, which pushes more debris up higher onto the beach, and particularly depositing at the base of the dune system at the back of the beach. So this is the storm strand line I've talked about. In many cases, the distance between these two, as in this photo, was minimal, and both were searched. While we made efforts to standardize portions of this method, it is not designed as a stringent scientific tool, but rather as one that can be easily repeated through space and time. This allowing a more general look into distribution over a much wider space and through multiple time frames. As such, its use is necessarily limited, but as our initial questions were quite broad, this was an ideal tool for generating spatial and temporal data while engaging in educational opportunities and sensitizing citizens to the issue of microplastic pollution.
Map of the seashore.
So this is the general area most of us are familiar with, but if it gets posted, then others may not know this area. You see NASA sort of there in the center. And we have Playa Linda Beach, one portion of Canaveral National Seashore. This is where most of our studies were done in this first year. And we actually have focused on a much wider area from north of Daytona, actually down to Sebastian, and even in some cases farther down south. But we're really just going to focus on, in this study, on the data that we collected at Playa Linda Beach. And, but for some comparison, because we did some monitoring through time, we want to also look at some of the sites that we did research at south of Port Canaveral. We did an initial pilot study at Playa Linda Beach employing the Nurdle hunt methodology north and south of each of the first 7 access points, so parking lots 1 to 7. And then we randomly chose 4 of these sites to monitor through time, at least twice a year, roughly corresponding to before and after hurricane season. So we did 4 sites south of Port Canaveral, and then also these 4
Sky
sites
view of the seashore.
From Playa Linda Beach itself.
Photo on the beach.
A total of 44 Nurdle hunts were completed in Canaveral National Seashore in 2019 and 2020 so far. The number of Nurdles found per 15-minute search ranged from 0 to 330. We made 5 observations at Apollo Beach during May of 2019, all of which were 0 values. And so we've discarded those observations for now, just to focus on the Playa Linda data. The rest of the analysis and discussion then is only for data collected at Playa Linda. We did not make observations at Klondike Beach during this time period, so we hope to do that in 2020. Mean Nurdle abundance per 15-minute search was 38, with a standard error of 10 and a 95% confidence interval of 17 to 58 Nurdles. This means that there's a lot of variability in the data, and that were you to go out to Playa Linda and do a Nurdle hunt, you'd have a 95% chance of obtaining a value between 17 and 58 Nurdles. Those we'll show later that actually during particularly the calm season, it's more likely to be a 0 observation.
Various
the graph
graphs.
of observations shows that in the shape of the curve is weighted here more towards lower observations with very few large observations. And so you can see here that we found a lot of 0 values, a lot of values less than 100, and really only 4 values greater than 100. Data were collected throughout the year, but not evenly distributed. So for the most part, they were collected within these 5 different months. And for the graph, you can see that the highest frequency of Nurdle hunts resulted there in September 2019. And so this was a time when there was a storm, and so we were able to get out really quickly after the storm. This sort of intentionally sampling during that month. We sampled several sites in Playa Linda after a storm late January, and in this case, January 2020. And these numbers were some of our highest recorded, with 1 observation in parking lot 12 and the beach offshore of that, having found 330 Nurdles in 15 minutes of searching by 3 people. We expected to see a more general pattern of Nurdle abundance related to hurricane season, but the data at this point do not support this, as numbers were very low in January of 2019. As a longer time series is available, we'll be able to answer this question more definitively. The monitoring data show the same patterns by date of sampling. So these are the 4 different sites that I had showed you before. So the blue is parking lot 4. We went south of the entrance point. So it's our monitoring site 4 south, and then you see 5 south, 7 south, and north. Those were those 4 points that I showed you before. The literature, so we're seeing at this point that we have quite a similar result for each of the different monitoring sites. That September after that storm was really the highest value that we found during our time period. The literature indicates that the nurdle abundance on beaches can change rapidly due to prevailing conditions. And so it may be that the temporal scale on which we have to make comparisons must be much finer than seasons. This also may differ by season in that the number of nurdles found in the stormier winter season may vary significantly, whereas during the summer, calmer season, there may be generally low observations.
Beach photo.
So given the temporal variability from season to season and also after storms, it becomes clear that in order to examine spatial patterns, data need to be collected within a fairly short span of time where there are no storm events. We have some indication that there is spatial variability within the Playa Linda section of the park during the winter season, but not during the summer season. On May 15th, we conducted 10 nurdle hunts ranging from parking lot 1 to 12. There were 8 zero observations and 2 observations where 1 nurdle was found. So just low observations overall during that summer time. We made a few other sets of observations during the more stormy season that gives us some hints that there is some small scale variability in how nurdles are washing up on the beach. For example, our 4 monitoring sites were examined shortly after a storm in September 2019. 3 of the sites had counts of 69, 74, and 91 nurdles, while the 4th was 144. The highest number being at parking lot 4, where the count of 74, almost half what was just a few hundred meters away, was at parking lot 5. On November 16th, 4 counts were made, with 14 being found at parking lot 1, while 82 were found at parking lot 10. Then our highest count ever of 330 at parking lot 12, while 112 were found at parking lot 1 and 141 at Eddy Creek. So there does appear to be a major difference in total numbers between relatively close sampling sites. It's unclear, though, whether those numbers make a difference ecologically, and so that's one of the questions we need to continue to examine.
Another graph.
The analysis of the monitoring site data seems to indicate variability in space and time. Sites at parking lots 4 and 5 had higher abundance than at parking lot 7 sites in September 2019 and January 2020. But all were very low at the other 2 dates. So there does seem to be some variability in counts among sites on the same day, but this needs to be investigated more systematically to determine if there are some oceanographic features which are impacting where nurdles usually end up, or if it is more serendipitous. Comparing the Playa Linda monitoring sites to those samples south of Port Canaveral, which were Jetty Park, Sherry Down, Laurie Wilson, and Tables Beach, we find a higher mean nurdle count at Playa Linda, but high variability. And using a t-test to examine the difference in means indicates that they were not statistically different. Graphing these by sampling date, we find similarly low values between the 2 locations in January and May 2019, but much higher values in September 2019 and January 2020 at Playa Linda. However, a significant but again unanswerable question right now is, what is a significant difference in nurdle abundance ecologically? There was not any noticeable relationship between the number of people searching and the number of nurdles found.
Beach sunrise.
This study is obviously in its beginning stages, and there's much more that we need to know in order to move forward. One of the main questions for the next stage of data collection is to try to understand potential sources of nurdles landing on Canaveral National Seashore. We will take a whole chain approach as advocated by FIDRA, working on this issue in Europe, and with whom we partner globally. Where are nurdles being produced in our region? We know that the states and the northern Gulf of Mexico are a major producer, particularly Texas, but where else are nurdles produced? Who is using nurdles in Florida? Where and how are they coming into the state? Is it truck? Is it train? Is it ship? We will also examine the literature and talk to experts in the local oceanography of the area and see if we can then map the overlap between nurdle production, use, transport, and oceanography to identify the most likely sources of nurdles washing up on the national seashore. We also continue to monitor our sites at Playa Linda and continue to compare those to those south of Port Canaveral. But after a more thorough analysis of the whole data set, we'll formulate some new hypotheses to better understand the factors impacting nurdles washing up on these seashores. We also want to have a particular focus on extending our observations to Klondike Beach and also collecting more data at Apollo Beach during the stormy season. Ideally, with interns and our university students, we can sample the entire length of the park within a short time span to get a better idea of the spatial variability of microplastics in the park, holding the temporal component to a minimum.
Black-neck stilt.
We are hosting short-term internships with university students so that we can train young scientists and expose them to these amazing habitats. We also hope to host longer-term interns starting in the fall, both ecologists and ethicists and theologians, to help us better understand and investigate microplastic pollution and the ethical issues surrounding its production. We also want to extend our studies to better understand the overall ecology of the sandy beach ecosystem. This includes the abiotic characteristics of the beaches, such as slope and sand grain size, but also biodiversity and ecology. We hope to develop a systems model of how these sandy beaches interact with the wider Indian River Lagoon system, particularly potential transfer of microplastics through our food chains. Research in California suggests that mole crabs are an entrance point into the food web for microplastics. Is that so here as well? How might those animals preying on mole crabs act as conduits for microplastic accumulation in the local food web? This is obviously a new study, and once the proposal is prepared, we'll seek permission for this research and also look for funding. Education locally, nationally, and internationally through social media and writing will continue to be an important part of our project. We are often asked on the beach what we are doing, and this provides an opportunity to engage beachgoers with information on microplastic pollution. This table was set up at an event at Sherry Down Park and is something that could be done at Playa Linda or other places in the seashore as well. This next photo, while taken at Sherry Down Park, illustrates the challenge and opportunity. While doing a nurdle hunt, I noticed a fine white line in the sand. It was very small microplastic pieces, and the line went right through an area where a small child was playing. We talked with the parents who had no idea their small child was digging through these plastic pieces. While not wanting to scaremonger, people need to understand what we are doing to our places of recreation and beauty, and positively given information that can help them make better choices that will ultimately reduce plastic release into our oceans, and therefore microplastics washing up on our beaches. We will continue to engage citizen science volunteers from local high schools and universities in the Titusville area, and adults, families, and we have a particular emphasis on trying to engage with local churches and get them out there and doing these citizen science studies and doing beach cleans alongside as well, as a side note. We have sought funding without success to engage lower income families who may not have the same opportunities to explore these amazing places as others, and we'll continue to seek funding to be able to serve the entire local community. We think the educational value of nurdle hunts is high. Participants see all the microplastic pollution while searching for this one particular type.
Hand-holding
As we better understand the sources and sinks of microplastic pollution on our shores, including the entire chain of release into the ocean from production through transport and the manufacturing process, we'll be able to address this issue systematically, and in so doing, reduce the number of nurdles within Canaveral National Seashore. Education on this topic sensitizes people to the issues, and we will develop and share resources already created by others that we believe can change current behavior, and that will ultimately reduce the amount of plastic in the ocean. We want to see a
final
change from
slide
an ocean
of
of
water
plastic to an ocean
and the
of hope.
Arosha sign.
We greatly appreciate the permission to conduct research in Canaveral National Seashore, and we look forward to being able to visit and study that beautiful and important place in the future.